Imagine stepping outside your front door, taking a breath of fresh air, and then seeing something utterly unexpected, something that defies our everyday experience. Instead of your familiar street, you're greeted by the swirling, vibrant nebulae of a distant galaxy, a cosmic masterpiece painted across the sky. What if you could reach the Andromeda galaxy, our galactic neighbor, in a matter of seconds, a blink of an eye? Not millions of years of arduous travel, but an instantaneous journey across the vast cosmic gulf. This isn't just the stuff of science fiction novels or fantastical movies. It's a real concept being explored in the realm of theoretical physics, the enigmatic wormhole. The universe as we know it is unimaginably vast, a seemingly endless expanse of space and time, and the speed of light, once thought to be an unbreakable barrier, is a hard limit on how quickly we can traverse these cosmic distances. But what if there were hidden shortcuts woven into the fabric of spacetime itself, wormholes, connecting seemingly unreachable distant points in the cosmos? Instead of painstakingly traveling through the conventional pathways of space, inching closer at a snail's pace relative to the universe's scale, you take a detour, a shortcut outside the normal confines of space and time, leaping across unimaginable cosmic distances almost instantly, bypassing the limitations of conventional travel. Wormholes fundamentally challenge our established ideas of space and time, forcing us to reconsider the very nature of reality, hinting at a universe that is far more interconnected and interwoven than we have ever imagined, a vast cosmic web waiting to be explored. The future of interstellar journey wouldn't solely be about building faster, more powerful ships, but about manipulating and folding the very fabric of space itself, bending the rules of the universe to our advantage. While still largely theoretical and shrouded in scientific debate, wormholes keep alive our burning dream of one day exploring the distant stars and unlocking the secrets of the cosmos. They serve as a constant reminder that the universe is brimming with untold mysteries, with phenomena that defy our current understanding, patiently waiting to be explored, understood, and perhaps one day even harnessed. The concept of wormholes, often depicted as shortcuts through space and time, isn't just a product of science fiction. It's not merely a plot device used in countless stories. The origin of this mind-bending idea can be traced back to one of the greatest minds of the 20th century, Albert Einstein, and his collaborator, Nathan Rosen. Their groundbreaking work took place in 1935. While deeply immersed in exploring the complex mathematics of Einstein's theory of general relativity, a theory that revolutionized our understanding of gravity, they stumbled upon the theoretical possibility of a bridge, a peculiar connection, potentially connecting two distinct and distant points in the vast fabric of space-time. This concept became known as the Einstein-Rosen bridge. Their work, at this stage, remained purely theoretical, a product of thought experiments and mathematical rigor. It was born from their investigations into the enigmatic nature of black holes and the extreme warping of space-time that these cosmic behemoths induce. Their complex equations suggested that under very specific and perhaps unattainable conditions, a tunnel, a shortcut, could theoretically connect two disparate regions of the universe, regardless of the distance separating them. This groundbreaking idea represented the very first mathematical description of what we now commonly refer to as a wormhole. Gravity, in Einstein's revolutionary view, is not a force in the traditional sense, but rather the curvature of spacetime itself, a curvature caused by the presence of mass and energy. To visualize this, imagine spacetime as a vast, stretched sheet, where massive objects create dips and indentations, and sufficiently extreme warping caused by incredibly dense objects could potentially fold the sheet upon itself, ultimately forming a tunnel-like structure. While Einstein himself remained skeptical about whether these Einstein-Rosen bridges could actually exist in the real universe, the mere proposition of the idea opened up entirely new avenues of exploration and research in the field of physics. Ever since that pivotal moment, scientists, researchers, and even dreamers have continued to ponder and wonder about the possibilities, asking what wonders, or perhaps dangers, might lie waiting on the other side of these hypothetical cosmic shortcuts. To visualize a wormhole, a concept that has captured the imagination of scientists and science fiction enthusiasts alike, Picture the universe as a flat sheet of paper. Imagine it stretching out infinitely in all directions. If you're an ant on one side and you want to reach a point far, far away, the long way is across the surface, a seemingly endless journey. But what if you could fold the paper, bringing those distant points closer together? Fold the paper, and suddenly your start and end points touch. Poke a hole through, connecting those touching points, and you've made a shortcut, a wormhole, a tunnel through space-time. On a cosmic scale, this means bending the four-dimensional fabric of space-time, warping reality itself. The immense gravity of black holes, those cosmic vacuum cleaners, could, in theory, create such tunnels, bending space to its absolute limit. The entrance might be a black hole, a point of no return. The exit a white hole, a theoretical opposite, linked by a wormhole, a bridge across the cosmos. You'd enter one mouth, plunging into the unknown, and emerge instantly from the other, defying the conventional laws of physics. No matter the distance in normal space, traversing light years in the blink of an eye. The travel time would be negligible, a mere fraction of what it would normally take, making the universe suddenly accessible, opening up a vast playground for exploration. That's why wormholes captivate space enthusiasts. They represent the ultimate shortcut. They offer a way to overcome the tyranny of distance and embark on cosmic journeys previously thought impossible. Here's the catch. Einstein-Rosen bridges are incredibly unstable. Like a paper tunnel snapping shut, a wormhole would collapse almost instantly. Even a photon entering would trigger its collapse, making travel impossible. The gravitational forces inside would be catastrophic, crushing anything that tried to pass through. Instead of a gateway, it becomes a cosmic dead end. The original idea connects two black holes, but crossing the event horizon means being pulled to the singularity, no return. Tidal forces would stretch and destroy any traveler long before reaching the center. According to current physics, traversable wormholes can't exist naturally. They're a mathematical curiosity, not a practical path. But this led physicists to a new question. Could we keep one open? To keep a wormhole open, physicists proposed exotic matter, a substance with negative energy density. Unlike normal matter, which pulls space-time inward, exotic matter would push it outward, counteracting collapse. If enough exotic matter lined a wormhole, it could stabilize the tunnel, allowing safe passage. This is the theoretical key to interstellar travel. The problem? We've never observed or created exotic matter in usable amounts. Some quantum effects hint at negative energy, but nothing stable or large enough for a wormhole. Exotic matter remains a hypothetical concept, possibly impossible to make. Without it, wormholes are just unstable quirks of math. With it, the universe could open up, but for now it's still science fiction. While science struggles with wormhole reality, fiction has embraced it. Movies like Interstellar, with input from physicist Kip Thorne, visualized wormholes as stunning portals to distant worlds. TV shows like Stargate SG-1 and Star Trek Deep Space Nine made wormholes central to their stories, turning galactic travel into routine adventure. In literature, Carl Sagan's Contact used a wormhole to explore humanity's first journey to the stars. These stories take creative liberties, but they've embedded the idea of wormholes in our imagination. They inspire us to dream of cosmic shortcuts and new worlds. Science fiction keeps the hope alive, fueling curiosity and wonder. What if these shortcuts could one day be real? So, are Einstein-Rosen bridges real or just theoretical curiosities? We don't know yet. Current physics says they're unstable without exotic matter, which remains hypothetical. But science evolves. What's impossible today could be reality tomorrow. The search for a unified theory connecting relativity and quantum mechanics may hold the answer. Each discovery brings us closer to understanding the universe's deepest secrets. Our quest is driven by curiosity and the urge to explore. The journey to understand wormholes links rigorous science with imaginative storytelling. Next time you look at the stars, see a universe of possibilities. The adventure is just beginning.